Today we'll be seeing in depth about these event streams, how they are used, how transformations are performed through these event streams, and how we can store the data into the event house. So today's hands-on, we'll be dealing with the event stream in detail. So first thing, to start with our hands-on, we'll create a workspace. So I'll give the workspace name as RTA event stream and apply it. So I'll create a new item. So first thing is, like as usual, if you remember in our data warehouse, first thing we used to create a storage that was lakehouse. So here, so our storage is event store. So first we'll be creating a store that is event store. So that is event house basically. So I'll give a unique name to this event house as RTA bicycle. So I'll be using some bicycle data, which is already there as a sample data in Fabric. So this will create a event house. So I'll just show you the interface of this event house. So this is the interface of a event house, as you can see. So this is the system overview, the original size and the compressed size and the event storage capability and what is the one lake availability and how many databases are available under this. So whatever I have created inside with the name of the event house will save as one of the databases, that is RTA bicycle. So and totally there are one databases, and coming to ingestion, if there is an ingestion of data to this database, you will be able to see it over here. And this is a place where you can monitor the queries if the query fails and what are the errors, what was the duration of the query, everything can be monitored under this. And if there are n number of activities, suppose if we have 2 to 3 activities in a stream, then we can monitor those things over here. Then if we have any workloads connected to it, you will see over here. And even the last 7 days events, what and all you have done for this database, what are the ingestions, what is the data that is getting streamed into this, all will be seen under this part. So this is the details of this event house, like where the data has been stored in the data centers and the URLs of this data event house, the QL event house, and if there are any plugins, you can just modify over here. So these are the different databases from where you can connect. So as of now, I have only one database, that is RTA bicycle database, and monitoring is nothing but administrating the whole workspace, whole event house workspace, and we can just add it over here so that in a regular general section of the workspace, we will be able to monitor this event house. As of now, let us not worry about this now. We will see this in the further hands-on. So now go to the system overview. As you can see the KQL databases over here. Under that, there is RTA bicycle. Click on it. So this will take you to a new interface, and you'll be able to see a similar interface as the SSMS or the data warehouse interface, where you will be able to see the query set, tables, shortcuts, materialized views, functions, and the data string. So as of now, there is no data inside this database, that is RTA bicycle database. We need to stream the data into this. So in order to stream the data, we need to create an event stream. So in order to create event stream, we have to click on this get data. So we'll get the data and click on this event stream. And as we don't have any existing event stream now, over the past hands-on, we had an existing event stream. So we went with the existing event stream. As of now, we have not even created an event stream. So we'll create a new event stream over here to ingest the data into this database. So I'll click on new event stream. So now I'll give the name for the event stream as bicycle data. So now this is the interface of an event stream. So now we need to bring the source data over here. So I can assume that the source data, I'll be using a sample data that is present already in the Fabric repos. So I'll be connecting the sample data. We can also use these connect data sources, like connecting an external data source if it is in AWS S3 buckets, or if it is in any other external source like data lakes in Azure or Azure SQL database or SSMS or anything, you can just connect it over here. But as we are dealing with the events, nodes. So if there are any streaming sources, we can connect to streaming sources over IoT sources or anything. You can connect it to this if it is in the event hubs or anything. So as of now, I'll use the sample data. I'll click on this. So there is a data coming from some kind of source, that is sample data, and it will be streamed to the bicycle data. So bicycle data is the event stream that we have created, and the source name is bicycles, and the sample data is also bicycles. And I'll click on add. So now source gets loaded to this streaming interface. So this might take a minute. So you'll be able to see the preview of the data over here. So as you can see, this is the data that is getting from a sample source that is present in the Fabric repo. So now let us connect this data to our destination, that is our event house. So in our event house, we do have this RTA bicycle database, right? We will connect the stream to that. So just click on this transform events or add destination, and I'll click.
Can you say again what we are connecting here?
So we are connecting to our event house. We are creating a stream in order to ingest the data to inside the state KQL database, that is RTA bicycle. Okay.
Okay.
So clicking on this, you will get a various options over here. Select the event house. So in the event house, there are two modes, that is direct ingestion and event processing before ingestion. So as of now, we'll go with the event processing before the ingestion, and we'll give the destination name as bicycle table. So this will create a table inside this RTA bicycle database. This will create a table over here. Let me just show you. Okay. So then we will select the workspace. My workspace is RTA event stream. So I have kept it like that. And in the event house, I'll select the RTA bicycle. And in the database, it is RTA bicycle again. So this KQL destination table, I will just create a new table with the name bikes. So I have created a table with the name bikes, and the input format for the table will be JSON. So this is the settings we have followed. So let me come again. Like we have selected event house for the destination. So the particular event house which we have created a couple of minutes ago, and we are giving the destination name event house, and the workspace name is RTA event stream. So we do have the KQL database as RTA bicycle. Only our thing is we need to create the destination table inside the KQL database. So the name of the table will be bikes. So once I click on save, and as you can see here, if you click on this publish, the stream gets updated. So this takes a minute to get the data preview over here. So still it is loading. Until we get a green tick and active sign over here, we will need to wait. So here you can see that the sources and the destinations are here. We are taking the source from the bicycles, and our destination is our event house. Let me edit the event house name to bikes table. So, and I'll also publish this stream so that the stream gets updated. So now my destination name will be bikes table. So this is one of the destination which I've created. So this data gets on updating as and when the stream is running throughout the canvas. Yeah, now it's active. So our destination is active, our source is ready, and our destination is ready. So let me go back and to our event house and refresh it. Okay, so here you can see that there are 780 rows ingested, and a couple of minutes ago from the last 4 minutes. And let us see all the things in our database. So let us click on this RTA bicycle database, and let me refresh the database. So under the tables, you can see the table name called bikes, which contains the stream data. So I'll just try to query and see the top 100 rows of this. So in order to query this, click on the table which you want to see the data. Click on this three dots, and you'll get the n number of options over here. go with query with code. And as of now, I'll just see the last 24 hours data. So this is the query for that. So bikes is the table name where ingestion time between now and minus 1 day. So till now. So it is telling that last 24 hours data has been bought over here as an output. So this is the set of code in order to get the most recent data that is ingested in last 24 hours. So do you have any questions till here?
Can you just say the step by step once more? No
Okay.
need to show, just
Okay, I'll just summarize that. So first thing is we created the workspace. Second thing is we created the event house. Okay. While creating the event house itself, we created a database name called RTA Bicycle. So when we reach to this database, the KQL database that is RTA Bicycle, we need to ingest the data to this database. So we clicked on this RTA Bicycle and we fetch the data by creating a new event stream. So in the new event stream, we use the sample data that is already present in the Fabric repo, and we created an event stream. And for the event stream, we have created a destination on under the same event house with a table name called bikes. So the destination name is bikes table under the event house, whatever we have created. So as you remember, the event source components will be sources, destinations, and transformations. So we are ready with the source and the destination. So our next step will be of transformation. So is that clear now?
yes. Thank you.
Okay. Now let us move to the transformation part. So in order to transform this data, right, we have to come back to this event stream back. So now we have the source, we have the stream, we have the destination. So there should be a transformation here. Let me adjust the screen now so that it will be easy to handle the things over here. Okay, now I'll start editing the stream again. So I'll click on this edit. So now I can edit this canvas. So I want to add a transform event. So I'll click on this and I'll search for group by. So I'll be using a group by, a simple transformation over this, and I'll just bring it to the center and I'll connect the bicycle stream to this. Okay. So now it's good. So now I want to group by the bicycles by the street names. So let me show you how you can use this group by field, I mean transformational event. So first thing is in this left side, we do have a configuration for this group by. So as soon as we select this, we will see the group by settings over here. So I'll give the operation name as group by street. So the bicycles will be grouped by street. So now the next step for the group by is to aggregate it. So I'll be using the sum over here as an aggregation function, and this sum will be put on one of the field, right? So one of the column of the data set. So I'll go with the no bikes. So the name of that function will be sum of no bikes. So and I will click on add. So this creates a group by on the bicycles where there are no bikes on each of the streets. So it will give the some streets. Now, in this group by aggregations optional, we can just select the street over here. And so once you have chosen the street, you can set a time window for how many seconds the group by should be applied. So as of now, I'm setting a time window using a tumbling window trigger or a function for every duration of 5 seconds. So this configuration will cause this event stream to calculate the number of bicycles. That is not actually no bikes, it is actually the number of bikes. So I'm sorry for that. So here it is about the number of sum of number of bikes, not the no bikes. So let me try to edit it. Sum of number of bikes, and so this configuration will cause this event stream to calculate the total number of bikes in every street for every 5 seconds. That is what the tumbling window does. So that is the time gap for this group by to act on it. I'll click on save so that the group by input is configured. Now still you can see that no output or destination is configured. So now let us configure the output data. So to configure the output data, as you can see, there is a plus sign over here popping up when you just click on this group by. Click on this plus icon, and in the various options over here, in the destinations, you can select the event house. Once you select this event house and edit this, we can see that the data ingestion mode, event processing before ingestion, and so I'll give the destination name as bikes by street. So select the current workspace. So my current workspace will be this RTA, and event house. I'll be selecting the bicycle, and I will go with my RTA bicycle database. And the destination table, I'll be creating a new table that is bikes by street. So this will be the table name. After that, there is a input data format which will be in the form of JSON, as the data is in the form of JSON. So let us keep this active ingestion after adding the data source checkbox with active and click on the save. So basically what is happening in this overall context is, so from the source, it is getting to the stream. From the stream, we are grouping by the data to get the sum of bike at every street over a time gap of every 5 seconds. And it will be loading into this event house with the table name that is bikes by street. So these both are the same databases, which the raw data is getting stored in the bikes table, but whatever the transform data I have applied the group by street will be stored in another table called bikes by street table. So let us go back to our event house. So before that,
Transformed data saved.
yeah, the previous raw data has been stored in the bikes table. So that is same data which is being streamed is stored in the bikes table. This is one table inside the database. This is the second table that we have created. And for the second table, we have created one of the transformation before ingesting the data to this second table. These both the tables are under the same database and the same event house. So let us just refresh it and also publish it. Now we will be able to see the preview of the data over here. So we have the number of bikes added over here. So here is the number of bikes. So column which has been the group by is applied over the street. So let us see how the output looks by using the KQL query set. So these are our destinations. We have sources and these are our destinations, and we do have transformation on this bike by street table. Now I'll be going to this RTA database, and I'll coming back to this database and I'll refresh it. Okay. So once you refresh the databases inside the event house, you will be able to see the second table which we just created, that is bikes by street, where we have applied the transformation. So you can see it over here. Now let us query this. I'll start querying it. So you can see the once I click on this, I'll be able to see the data preview schema insights, like how many columns are there, like what type of data it contains and all. So moving back and click on this three dots, again query with code, and I'll see for show like 100 rows. So this will bring the top 100 rows with the sum of the bikes per street with the window end time. So you can see that there is every 5 seconds gap in this. So this is the street name and this is the number of bikes in the street. This is the street name. This is the number of bikes in the street. So like there is a Scala street where there are 12 bikes. There is a Howland street where there are 25 bikes. So like that we have got some 100 rows. So you can even query this database with the help of SQL too. So we do have an option of that. So that will be dealt with the part of querying with the event house. So now let us modify this query and So I had just changed the name of that column as NO to number. So that was the mistake over here. So I'm just summarizing the total number of bikes with the taking the window time in a descending order and a street in the ascending order to get the total number of bikes. So that we will see the total number of bikes in the ascending order along with the time. So this is how you can query the data that you have already transformed. Query the tables that are in the KQL databases. And let me just try to write another query if it works good. So basically here, what is the difference between this and this is here we are just taking the bikes by street table directly and seeing the output over here. We are just optimizing the query to summarize a table to aggregate the total number of bikes for each of the street at different time windows and then sort the results by the window end time and the street in descending and ascending order. That's the major difference between these two things. So, are there any questions over this? So, now let us go back to the stream. So, it's live over here. You can just click on it. So, if it is live, you want to edit. If you click on edit, it will go to the edit mode over here. And these are the sources and destinations. So you can also create dashboards with help of this data, which we'll be seeing sometime later when we are dealing with the dashboard. If there are any questions, and I am happy to address it now. And one more important thing is we can see the system overview now. So the original size of this database is 76.2 KB and the compressed size is 19.1 KB and the storage resources are now 19.1 KBs. So there are one database and from last 15 minutes there are activity over this database and there are almost like 2K rows ingested to this database. And you can see there were one error and one duration, and there are zero cache misses. And we ran almost like 15 queries, like 15 queries in the sense I have ran like 2 to 3 times over the same query. So it has taken over the 15 times. So this is the database name. It is the RTA bicycle is the database name. First, we created the bikes table and here is the command which has been used in the backend of that canvas to run it and create it. And we also used the bikes by street for transformation and creating it. So we could see that over here. So this is how you can see the details of this KQL databases over here. So, are there any doubts? So, this is about the event streams, like how you can ingest the data and how you can transform the data. So, for the last time, let me just glance it through what has been done in this hands-on. So, first thing is we created a workspace. So, once the workspace has been created, so let me go to the workspace. Okay, RTA event stream was my workspace. So under that event stream, I mean the workspace, first I created event house. So once I have created the event house, started ingesting the data to this event house through a event stream. So in order to create this event stream, I directly went through this database. So once I had clicked on this database, yeah, there was an option to get the data into this database by using the get data option. So from there, I navigated to the stream creation. So we created an event stream. Once the event stream was created, we bought the source data for the event stream from the Fabric Git, I mean, repos that was already present as a sample data in the Fabric. I just picked up the bicycles data and created the event stream. Once the stream was created, the source was created. Then I configured this destination and I gave table name as bikes to store the raw data in this bike table. Once we stored this data in this table, we saved this canvas and published it. Once it was published, we went back to the database and queried the raw table by getting the data for last over the last 24 hours. Then again, we came back to this event stream and created a transformation event, that is group by street, group by transformation over this bicycle stream. And then we loaded that transform data that by applying a group by street option, and gave the name of the table as bikes by street table. So once the data flow was completed, we just saved the data flow over the stream and published it. So once the data was published, again we came back to this RTA bicycle, and we queried the same data. Basically, by applying the 5 second time window, that is the tumbling window option, we have streamed the data for every 5 seconds by grouping it over the street. So we got the number of bike over different streets for every duration of 5 seconds. We aggregated the total number of bikes for in every streets. So that is what we have done and queried as an event stream. In all the ways, we have covered like three components of the event streams. Those were source, destination, and transformation. So we created a source which was available in the fabric, and we created a destination with the event house, and we created a database inside the event house as RTA bicycle. Then we applied transformation and created a table to store the transform data, that is bikes by street. So all the things are covered. Okay. Are there any questions?
Nanda, there are shortcuts here, right? Is it the shortcut between two event houses, or what exactly this does?
I'll be speaking about this in the querying part. So this is
Okay.
only the event stream. So I'll be discussing each and every parts of this in the querying part of the data KQL databases. So I'll be dealing with the materialized views, functions, and things. So I can explain. So as of now, if there are any streams outside Fabric or somewhere in the lakehouse, you can bring it over here. So that is why the shortcuts are there. We'll go in detail once we have that event house hands-on.
Okay.
Nanda,
Mm.
uh, we are connecting the data source and getting data from there, and
Mhm.
we save the data by creating a table in the event house. So that table is called the destination, right?
Yes, those are the destination tables.
Okay.
So
By
these both.
using that destination table, we are transforming the data and
No, 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 no.
inserting in another table.
No, 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 no. We have just pushed the data into, see, as you can read this map, right? So as you can see here, first we created this branch where we just bought the data from the source through the stream, and we pushed it to a single table, that is bikes table. Now for transformation, we fetch the data from the stream itself. We didn't fetch the data from this table. We fetch the data
Okay.
from the stream itself. We transform the data and we have pushed it to the another table in the same database by giving the name as bikes by street table. We have not transformed the data from this table. We have transformed the data from the stream itself.
Okay.
So the
Mhm.
incoming data for this group by is from the stream itself, not from this table.
Okay. Then why we are creating this table?
Like example, like if you want to store the raw data, like we want to check whether the data is incoming properly or not, then this is the way we check it. So you'll create an event stream to make sure that your data is running properly. You just save it in one of the raw tables. So once you're confirmed that okay, your data is running fine through the stream, then you can apply transformations over that. Later on, you can just delete this. This will be kept as a backup to check whether the data is getting streamed properly or not to the destination.
Okay. So after transforming the data, we saved in another table, bikes by street table, right?
Yes.
So that is also a destination.
That is also same destination of the event house. It is the same destination, just a different table name. You can imagine like say something like pushing the data to the same database in a new table.
Okay. Mm.
So as you can see here, so first we created the tables. Under this tables, you can take this as a database name. There are tables under this database. So bikes is one of the table. Bikes by street is another table. So bikes by street, we have applied transformation on the data that is incoming from the stream. So whereas bikes is the raw data that is incoming from the source stream and loading it over to this table. If there are no more questions, we can wind up for the day. Okay, then I guess I couldn't see any questions as of now. So please practice this so that you'll also have a good experience with the real-time analytics.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.